6x plus 5 times x cubed minus 2. So then the derivative would be the first function times the derivative of the second plus the second function times the derivative of the first. And then I just simplify it, right?
So wait, are we going to
18x to the third plus 15x squared plus 6x to the third minus 12. How about 24x to the fourth plus 15x squared minus 12? Rightio? All right. Try the next ones. If you're doing these right. Yes, sir. It would be. What the heck did I do?
Nobody knows.
All right. X to the, oh, that's third. I was good there. I need to fix this one. I'm out of sync again. Love it.
We need to calibrate.
Yeah. First, I want to see if I can focus the darn thing. Focus.
What'd you get from 3? Oh, what'd you get from 1? What'd you get from 2? Oh, jeez. They call me the flying monkey.
You sure did it right?
Did you do it right? No idea if they're right. It could be. Those are T, and that's plus that's T. I should really like try to make the T's obvious. Can I just change them to X and with
Oh, it cleaned it up. What the heck?
Go, press the HD mode.
All right.
Get the brightness.
Why did it suddenly fix that?
Make it like the sun. Make the brightness 100.
It suddenly woke up and said, "Oh, I'll fix that for you." That flickering? You didn't want that? 3 would look like h of t is equal to t to the 1/3 power t squared plus 4. And I'll be frank, I wouldn't use the product rule on this normally. What would I normally do? Dulce? Yeah, I distribute that through and use a power rule. It'd take me a lot less time than what I'm about to do. So that isn't thrown away. Okay? Yeah. There will be times I'm going to force you to use a product rule, but this isn't one of those cases. Wait a minute, I would go, so since we're supposed to use a product rule, I'll try to do so. And I go 1/3 t to the negative 2/3. I did it in a different order than I normally do. Let me do it in the same order so that I don't confuse anybody. So I got t to the 1/3 times 2t plus 1/3 t to the negative 2/3 times t squared plus 4. Ew. So this becomes 2t to the 4/3 plus 1/3 t to the 4/3 plus 4/3 t to the negative 2/3. Ow. Add those up, I get 7/3 t to the 4/3 plus 4/3 t to the negative 2/3. Again, I would use the product power rule on that one.
What?
Did you do it wrong?
Probably not. I have a bad track record here. No, well, I got 2/3 t negative 1/3.
I got that. Wait, no. What is that last power?
Negative 2/3?
Okay, yeah, I got that.
Okay.
What about the first one, though? How'd you get 7/3? Wait, what?
7/3 because I got 2. To make a common number, that'd be 6/3. Plus 1/3 would be 7/3.
I don't think so. Wait a minute. Because if you go 1/3 times 2, you get 2t to the
You don't times, you're adding. I have 2 pieces plus 1/3 of a
It'd be
pizza.
2 and
I have
1/3?
7/3 of a pizza.
Well, then how did it work for the other
2
one?
and 1/3 would be fine.
How did it work for the other one? How did I get one of them right and the other one wrong?
Because here we're actually multiplying. Here we're adding.
Yes.
So you have to do different things with those. All right, if you haven't had a chance to do 5, skip ahead to 5. We'll do 5 together in about 2 minutes. All right, 5. 5, what does 5 look like? 5 is f of x equals x cubed cosine of x. So then I go, the derivative would be x to the third times negative sine x plus 3x squared times cosine x. I would bother to simplify it. Shh, all right.
What's the quotient?
That's what we're going to talk about now. So we got that?
Oh, no. Oh, don't give us the quotient. Oh my God.
Yes,
that does not look fun at all. I'm sorry. Please no. No.
It's okay, I'll blame it on Peter.
Next page. Yes,
You
please
always do.
So Peter asked a question, what do we do when we divide these?
I did not.
He didn't actually ask that question, but I thought I'd say it anyways. Oh, wait. We're still on this one?
Yeah.
Hold on.
Peter, why do you do this to class all the time?
What is residence?
Proofs at the top for your moral edification. Those of you who enjoy such things should spend some time looking at that proof. The punchline of the proof is the derivative of f of x over g of x, this is called the quotient rule because we're dividing, is going to be, now the hardest part about this rule is always going to be as follows. Remembering what goes there first. I always pull up the bottom first the way I look at it. So it's going to be g of x times f prime of x, or the derivative, minus f of x times the derivative of x, derivative of g, all over g of x squared. Again, the y that's embedded in that proof. We use this when we have two things divided. All right? So in example number 7, I have x over x squared plus 1. I want to take the derivative of that, correct? So I bring up the bottom first, times the derivative of the top, minus the top times the derivative of the bottom. So I'm following this model, right? So f of x is top, g of x is bottom, right? So first thing I do is I put the thing on the bottom on the top. Boom. Times the derivative of the top, which is 1. Minus the top times the derivative of the bottom.
Okay.
Yes?
Can you pick either one to be g of x as long as you plug it in?
No, the one at the bottom is g of x.
Okay.
Bottom has to come up first. That's the thing you're going to forget. This has to come up first.
G of x. God.
All over x squared plus 1 squared. And that's just a matter of simplifying it. X squared plus 1 minus 2x squared, all over x squared plus 1 squared. So I would get negative x squared plus 1 over x squared plus 1 squared. This kind of symmetry appears a lot.
I see.
I'm also going to allow you, for the most part, to leave that as a square in the bottom like that. It just, you can factor that, you should FOIL that, but on the AP test they oftentimes let you do that, so I'm not going to force you to do better than that. Kim, did I do good? You ready to do the next problem then? Ready to try the next problem? Thank you. Try the next problem.
You did well, sir.
I doubt it.
But for number 8, yeah, do number 8, because you get.
Do number 8. Okay, so I'm going to start off the bottom. I go 2t minus 7 times 2t minus t squared plus 2 times 2 all over 2t minus 7 squared. Agreed?
Now, wait a minute. Oh, no, that's fine. When you get to it.
So then I'm going to go 4t squared minus 14t minus 2t squared minus. Watch this minus here, guys. This should be minus 4. All over 2t minus 7 squared. And then I've got 2t squared minus 14t minus 4. All over 2t minus 7 squared. And that's pretty much where I would leave it.
Oh. So wait, what if we want the answer and we do that one, and then we factor both the top and the bottom?
There's no equals
And
on the other
then-
side, so there's no way to get an answer. All you can do is simplify.
Okay, well I got the right answer. We're okay. This 8 equals this. I feel
So the first one times the derivative, the bot what?
Just ignore it. Just
I'm here, Brent.
It's like, let's say t to 3, 3 to 3rd.
Just ignore it. I know the. Just ignore it.
It's gonna take my bite.
However you want to describe it. What did I do it? X to the 1/3. Or x cubed plus 1. So this is going to be
Oh no.
Just because it's going across the page again. I literally have this worksheet.
Oh my gosh, this is a hole that I
Close to my ex. You have to step across the page. Like 8, 9, 10, 11, 12, 6. What?
yes, ma'am.
My handwriting's too big.
Down.
The 7/3. When I did it, I got negative
Uh-oh. This when you're multiplying exponents, you add them, right? So I've got 3 minus 2/3. I'm going to get a number bigger than negatives, right? This is 9/3 minus 2/3. That'd be 7/3. Yeah.
We swapped because I wrote this. Now you wrote it like.
we can't add any of these because we need the same power.
Actually, that's
Okay, what'd you get?
It's so ugly.
it's horrible.
It's so ugly.
Actually, I didn't start typing.
What a potato.
President, why you gotta be so-
Please God, let that not be 9, because
Okay,
I,
Walker, 10, 11, and 12 are like way easier
Wait, where-
than 9. 9's like the worst one on
Wait a
the
minute.
9 is the worst one.
9 is the worst one on the page.
Shh, tell them that. It's going to increase their morale. They're going to start to be happy. Look, Kennedy's already starting to do more work. Good. It was like, I'm done for the period, and then you said the next ones are easier, so all of a sudden she's working again. Good.
Sandy was done for periods.
Wait, what? How did you even?
What?
What? That doesn't even make any sense.
What did you wrong?
Everything. You did everything
All
wrong.
right. Shh. Don't say. Which question?
On like the third step, I put 1/3 next to the.
How'd you get 8 over 3?
Shh. Don't say what?
Yeah, how do you get that? Like,
How to get what?
8 over 3.
Like the 7/3. I'm confused.
7/3. Okay, folks. These are exponents, right? When I multiply the exponents, I add. When the base is the same, I add the exponents, right?
Oh, you add them.
Yeah. And when you add the exponents, that's 9/3 minus 2/3. That's 7/3.